dear students, I'm Meghamala, and now in today's topic we are going to discuss how can we connect the port connection rules. Okay, so port connection rules, how many rules we need to, what are the rules that we need to follow and how many are there. So we know that a module, okay, so this is a module, right? So for this module, each and every module, we have the inputs, we have the outputs and also the in-out ports, right? So this is the input and this is the output, and here it is the in-out port, in-out ports. So input is nothing but the entry of the variables, and output is nothing but the exit of the variables, right? So here for this ports, input port, output port and the in-out port. So what are the rules that we need to follow? We will discuss now. So system Verilog, it extends Verilog port connection by making all variable data types available to pass through ports. So obviously all different types of variables, okay, different variables, different data types, we are just allowing it into the port, into the module. That is nothing with respect to the input. Some variables are with respect to the input, we are making them to allow into the module, and with respect to the output, we are obtaining some different variable based on the data types that we are given, right? This is what we observe, okay, in the Verilog. Then it does this by allowing both sides of port connection to have same compatible data type and by allowing continuous assignment to variables. So how can we observe, or else how can we give the variables or data type into the port? Input port or output port or in-out port is based on the continuous assignment statement. So in the previous classes, we have discussed different types of statements, right? So continuous assignment statement, through continuous assignment statement, we can easily, by considering different data types, okay, different variables, different data types, we can easily get an access to get into the input ports or else the output ports or else the in-out ports. And also it creates a new type of port qualifier reference to allow shared variable behavior across a port by passing hierarchical reference. So what happens is, based on the by considering the continuous assignment statement, we can know the priority, right? We can know the references. We can know a new type of port qualifier. That means what, based on the priority or else based on the grades, based on the levels, we can easily we can give a new port of, okay, new type of port qualifier with respect to the reference, or else we can just to allow the shared variable behavior, okay, across a port by passing a hierarchical reference. So by passing the hierarchical reference, we can able to know how a port can, or how a module can receive the inputs, okay, from the port. And then we know that for a module, we know the input, output and in-out ports, right? So what is the input internally? It must always be a type net. Externally, the inputs can be converted to variable of type reg or net. So in the inputs, okay, in the port list, when it comes to the inputs, usually the R inputs will be in terms of type net, and externally, internally we can see the inputs are in types of type net, that is A, B, C or declaration of the variables. And then externally, what we can see that inputs can connect it to the variable of type or net. So output, at the output, we can see externally with respect to the input port, we can see the type net. The variables they are connected with respect to the type net or net. Okay. Then coming to the outputs, in the output ports, we can see internally they can be of net type or reg, okay. Likewise, the input. Externally, the output must be converted to a variable of type net. So internally, we are saying something that we are allocating some variables pertaining to the net or data types. But externally, we are saying that based on the connections or based on the physical connections between the among the different registers or else the different modules, what happens is we are observing the output, they are connected in terms of type nets, okay, type nets or reg. Then, what are the in-outs? In-outs are nothing but internally or externally, they must always be type net can only be connected to variable net type. So what is this in-out? In-out port is nothing but, you can see here the name input and as well as the output port. So the combination of both in-out ports. So we are saying that internally or externally, in either way, internally or externally, they must be a type net. Okay, they must be of a type net. Can only be connected to variable net type. So for example, here for in-out ports, I can remind you an example. The best examples are multiplexers. Okay, the best examples are multiplexers, encoders. So why? Because in the multiplexer, based on the selection lines, and based on the control signals, we can able to get the output, right? The output is purely dependent, or else the output is observed only with respect to the enabling of this selection lines and as well as the control signals. So in that way, we can say that the in-out ports, internally or externally, they must be always a type net, okay, and can only be connected to variable net type. Okay, few variables, I can say few variables are via reg, right? Few variables are via reg, like that. Okay, so this is nothing but the in-out. And now width matching. So what is this width matching? Is the width with respect to the input and width with respect to the output, how it is going to be matched. And now it is illegal to connect internal and external ports of different sizes, but beware, synthesis tool could report problems. So here there is a problem in this particular scenario, that is width matching. It means that it is legal to connect obviously the internal and external ports of different sizes. See, this is a module, okay, this is the internal input and this is the output. There should be some connection, right? There should be some connection. And this is the in-out port, and this is the output port. This is the input port. So if you observe, there must be a connection between the input, output and in-out port. The width of the input, it may change with respect to the output. Okay, it doesn't mean that all the ports, input, output and the in-out ports are to be in the same way. Okay, the dimensions may change, the width may change. Okay, but you can see that when it comes to the synthesis process, okay, for the front end, if you are giving all the variables to the input port, output port and in-out port, but whereas in the back-end process, that is the synthesis, at the synthesis time, you may occur some problems. You may occur some errors based on this width matching. Okay, so make sure that the width plays the width is a very important point to be remember if you are constructing your module. Then unconnected ports. So what is this unconnected ports? Unconnected ports are allowed by using comma. So these are the unconnected ports. Sometimes what happens is in a sequence, in an array, we can write A, B, C, D, E. Okay, so these are nothing but these are the connected ports. Okay, A is connected to port 1, B is connected to port 2, C is connected to port 3, D is for port 4 and C is port 5. So what is this? This is a connected port, connected module. But whereas if somewhere due to the mismatching of the connection or is due to the mismatching of some other disturbances, okay, what happens is there is an unconnection between the modules or the variables or peripherals. So what happens is in the representation, in the synthesis process, if you come across A, B, that means what? There is an error. That means input port is not connected to the output ports, right? So here my input is A, output is B. So in my coding or in the synthesis process, I have observed that A, B. So that means what? The two ports are not connected. Okay, this is how using the comma we can able to identify. Then the net data types are used to connect structure. The net data types are used to connect structure. A net data type is required if a single signal can be driven a structural connection. So here a net data type is required if a signal can be driven a structural connection. So here if a signal is wanted to make if you want to describe a particular signal, okay, in order with respect to the structural formation, then what is then we require a net data type. Okay, then we need a net data type. So this is an example. If you observe register or net, so these are the data types. So these are the data types that we can consider with respect to the input port, and also for the output port we can write in terms of net or registers, either way. And then for in-out ports we can write the nets. Okay, so these are the different data types. Okay, these are the different data types pertaining to the input, output, and as well as the in-out ports. So there are two methods of making connections between the signal specified in module instantiation and the port in a module definition. So here there are two ways to make the connections. There are two methods for the connection of two different ports. How is with respect to the module instantiation. Okay, that is module instantiation, and also with respect to the module definition, instantiation and as well as a definition. So what are those two methods is connecting by order list. So now we can connect it by the order list, and the second one is we can connect the ports by the name list. Okay, first one is we can collect the port 1, port 2, port 3, port 4. So we can collect all these ports. Okay, port by the order list. So first come, first serve. Order, second order, third and the fourth. And the second one is we can connect it by the name list. Okay, based on the names. So now we will see how can we connect the ports by the order list. Order list is a simple method for beginners. So it's a simple, if you are as a designer, if you have started your career as a designer in the Verilog, remember that you can go with respect to the connecting by order list. So it's a very simple and easier to follow, and the signal to be connected must appear in the module instantiation and in the same order as the ports in the module definition. So here, what is how are we saying that the connection by order list is the signal to be connected? Okay, the signal to be connected from the input to the output, it must appear in the module instantiation. So in the module instantiation itself, it should appear saying that there is a connection between the input and as well as the output, right? And then also in the same order as the ports in the module definition. And also in the module definition, it should be clearly appear saying that saying the same order is followed or not. Okay, in that way, we can make sure that there is a connection between the ports. So the best way is to go is connecting by order list. And the second one is connecting port by name. Okay, so what is this? For large designs, for complex designings, okay, in order to design a complex building blocks, for complex designings, where module has approx 50 ports or above. Obviously, in the complex designings, the modules we have 50 modules, right? 50 modules. So these are the very huge, right? This is very huge. Then, in this situation, remembering the order of the ports in the module definition is complicated and impractical. So obviously what happens is if your designing is complex, it means that it requires more number of modules, right? More than 50 modules. So in such case, it's better to connect by the name of the module. Okay. But even though if you connect the name of the module, but the thing is, it's very impractical and complicated. Most of the times you don't prefer such kind of connecting ports by the name, as it is very complex to design and it is very chaos. Then Verilog provides a capability to connect external signal to ports by the port names rather than by position. So the Verilog, what it is it just help us. Okay, it provides the connection external signals to port by port names. So the best thing that Verilog is, it just gives a name of the ports as per the priority, okay, rather than by the position. They just give as per the names observed from the Verilog. We can make use of those ports in the construction purpose rather than going with the positions. Then another main reason for connecting ports by name is that as long as port name is not changed, the order of ports in the port list module can be rearranged without changing the port connection in module instantiations. So this is very clear. For example, for port 1, I have given the name as A, and port 2, I have given the name as B. Port C as name C, and port 4, I have given the name as D. So these are my names, port names. So what happens when I'm constructing a module? I have to consider all the ports with respect to the names, right? That means what? I have to consider A1, B, second, third, C, and D, finally fourth, right? But it will be more easy if you don't change the names. For example, when I'm constructing a particular design, what I'll do is I'll consider the names of the ports in the Verilog with respect to A, B, C, D as 1, 2, 3, 4. And sometimes what happens is there's a possibility of changing the names. If I don't change the names, then it will be easy for me to reconstruct the module. Okay, that's what it's saying. If you don't, the module can be rearranged without. That means I can rearrange. The structure of the module can be changed if you don't give the name. Okay, so the best way is don't give the name first. If you don't give the name, then it will be easy for you to rearrange the structure, rearrange the module. Okay, that is one of the advantage. I can say that if you go as per the connecting by port names, but overall I can say that it's a very complicated because of the complex designing structures. Okay, and it's very impractical. In the practical way, we don't consider this port by name list. Only the thing we can go as per this connecting by order list. Then port variation. So here we have different versions in the port variations. One is IEEE version and the second one is ANSI C style versions. Okay, so these are the two different versions of how to connect up ports. Then here if you observe is a model ABC, and here we have the inputs A, B and C with respect to the bits, and you can declare them as WI as wire. Okay, why? Because I'm connecting all the ports A, B, C. How I'm connecting A, B, C? Because through the wire, right? So these are the wires. So now declaring the wire A, B, C and then end module. And now what I'm doing is module test. Now I'm going to test ABC, how the connections are good, whether they are good or any unconnecting ports are appear. So for this purpose, I have to go for the test. So module test ABC, input AB and output is C. So by default, C, the port C is changed to be a register type. So obviously on my output, I'm going to store in register type. C is equals to A and B. Okay, the port connection I should show that A and B. If I observe any A comma B, then it is nothing but they both A and B are unconnected. Okay, if I observe A, B, it means that both are connected. Okay, so for testing purpose, I have to mention all these things. Then finally, end module. So this is one way of this is the original IEEE version of declaring the ports. Okay, declaring the ports, a connection of ports. So here I have to first name the names of the ports. So here we have given the names of the ports A, B, C, all of 8 bits. All of 8 bits, right? So these are the names. A, B, C are the names. Okay, then okay. So this is a one way of original IEEE version, and now in ANSI C-type style of port variations, we see that module test input ABC, okay, and output is C, design content end module. So these are just declaring the input, output, and as well as the input and output with respect to the variables that is considered. And then for the testing purpose, module test, input wire. So for the connection purpose, ABC wire, design content, end module. So here, as is ANSI C style port connection version, okay, port variation, it is just observed or was introduced in 2001, and it allowed the type to be specified inside the port list. So inside the port list, everything is specified clearly. Okay, inside the port list. And usually the port list contains input port, output port and in-out port, right? So in this ANSI C style, okay, C style port variation, we are seeing that inside the port list, everything is declared or instantiated properly. So if a port declaration includes a net or variable type, then that port is to be considered completely declared. Yes, obviously, remember that in the port list, if you are considering or the port declaration is followed with respect to net or the register, okay, net or variable type, net or the variable type, then it is completed. Okay, if you are missing anywhere instead of variable type, some other coefficient that you are adding there, it means that it doesn't complete. The declaration is error. The declaration, some error is observed. Then it is illegal to declare, redeclare the same port in a net or variable type declaration. So it is illegal. That means we cannot go for the next option. That is within the, okay, it is illegal in the same port. We cannot, once in the port, once if you observe A, B, C, D and E as the output and both are the input, it is very illegal that you have, you need not to mention again inputs like A, B, C, D, E, right? Again, if you are mentioning A, B, C, D twice, then that is illegal, right? This is illegal. So that means what? You need not to, that's totally wrong if you are declaring inputs twice, and as well as outputs also. Okay, so this is a one way of representation, or it's a variation in the ports. This is another style. And see here, see a model test AE, wire signed, via AE illegal. See, this is illegal representation. Why am I saying illegal representation? Is wire sign. 2 times you are representing wire, but something is missing, right? So wire signs are illegal representation. So what am I doing is just to set it what the ports declared net or net variable type. So input AE. Directly I am going to the statement register AE. This is data type, net data type, register AE, and then reset of the design end module. Okay, if there is an error, if you in this particular, why? Because it is an illegal way of representation. Illegal way of representation, right? So there is a error which is found, and then this is the perfect one. So this is the perfect way of writing your code in terms of the port declarations or the port variables declaration. Okay, so this is all about the port connection rules. So there are some rules to follow. For the, in order to connect a port, input port to output port, and also from the in-out ports to the input ports and in-out ports to the output ports. Okay, those port connection rules are very much important. Why? Because this is the basic thing. In our Verilog code, port list is a basic thing. That is an instantiation or it's a representations of inputs and as well as the output. Remember one error, that if your inputs are repeated more than twice, then it is an illegal way of writing the port variables, port declaration. Okay, so I hope you understood today's class, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.